So Mr. Baker is holding an old-fashioned water sampler, and what you would do with this is you would drop this down to the bottom of the lake, and or to whatever depth that you wanted to collect a sample from, and once you get it to the right depth and it's filled up with the correct water, you then give the handle a good shake, the rope, you give it a good tug, go ahead, and it captures your water sample, and then you can pull that back up to your boat, and then you can measure the temperature and the dissolved oxygen and anything else that you want to measure. There's lots of different versions of these, but this one with the wiffle ball is kind of cool to look at. So now we're going to play Name the Water Quality Equipment. So first off, I'm going to go to this nice piece of technology right here. Okay, what is this?
Dissolved oxygen.
It is a dissolved oxygen sensor, also a temperature sensor. Now this is a lot more convenient than using that water sampler that Mr. Baker just showed us, because you can just drop this sensor down. It's got weights on it. Just drop it down using the cable to whatever depth you want it to go down to, and it tells you the dissolved oxygen and the temperature. And we're going to use that to make profiles to show us what the lake looks like. That's an oxygen sensor. Anybody remember what this thing is called? Brandon?
I don't know what it's called, but I know you drop it to the bottom and you can pick up samples of detritus on the bottom.
It picks up samples of detritus, the rotting stuff on the bottom. So I drop it, it goes to the bottom, have it tied to a rope, I pick it up, and it brings up a bottom sample. Anyone remember the name?
Bottom sampler.
It's called a bottom dredge or an Ekman dredge. Same thing, bottom or Ekman dredge. Does anyone remember what this is used for?
Oh. To catch phytoplankton?
It's to catch plankton. It's a plankton net. And it has a metal hoop, and you drag it up through the water column, and you can collect plankton, and you can even measure the plankton quantitatively, because you can calculate the volume of water that it moves through. If you know the area of that circle, the area of this hoop, you can multiply it by the depth that you pull it up from, and you can figure out the volume of water that you filtered. And you can figure out how much plankton per unit of volume that you collected. Anyone remember what this thing is?
It's a net.
It is a net. It's called a kick net. It's got this nice triangular shape. This is for collecting benthic macroinvertebrates. Benthic macroinvertebrates, or BMI, benthic means bottom. So if it's benthic, it's on the bottom. Macroinvertebrate means, well, invertebrate doesn't have a backbone, and macro means you can see it without a microscope. You can see it with the naked eye. So you use this, you kick it along the bottom of a stream bed or a shoreline, and you pick up the benthic macroinvertebrates. And then we have a macroinvertebrate lens that lets us see them. You put this over the top of your macroinvertebrate, and it magnifies them. We also have a nice diagram here that shows all of the different kinds of macroinvertebrates. And on the back side, it also even shows all kinds of fish species. We'll talk about that later on. Last but not least is this thing. I have a measuring tape connect to this round black and white disc. What is this thing called?
Seki Disc.
A Seki Disc. S-E-C-C-H-I. Seki. This is a Seki Disc. You drop this down to a certain depth, and you look from the side of the boat through this scope here, and when you look down through the scope, when you can no longer see this, you find the vanishing point. That tells you how transparent the water is. So the deeper it goes, the greater the transparency. The opposite of transparency is turbidity. So if the Seki disc goes deeper before vanishing, you have high transparency, low turbidity. If the Seki disc doesn't go very deep at all, then you're going to have low transparency and high turbidity. And turbidity is usually caused by algae and material in the water column.